15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Oh, I was doing a bit of a rockin' and bopping there to that introduction. I do love that. Welcome to Space Nuts, episode 266. I'm your host, Andrew Dunkley. Thank you for joining us once again. On this week's edition, a new way to measure the mass of a supermassive black hole. Last week, I told you about the thumb method. I think it's the same thing. We're also going to look at a few quick stories. The NASA moon mission looks like it'll be delayed, as will be the launch of Boeing's Starliner. It's got a flat tyre. And Mars Perseverance has failed in its first attempt to get dirt. It's not that difficult, people, but NASA is blaming Mars for the problem. We're also, it's not a question, it's a correction. We were talking about the issue with the ISS recently and that Russian probe that suddenly lit up and spun the ISS around. Mike DeRosa has contacted us to say he's recently discovered the show, but he's also got a very good explanation as to what happened with the ISS the other day. So can't wait to share that with you. And Matt from chat wants a dumbed down version of dark matter. So we will do all of that today. And it is my great pleasure, as always, to introduce astronomer at large, Fred Watson, because I could not do this by myself. It would be very short. Hello, Fred.
Andrew, you'd make a cracking good job, actually. Come on, you've done 266 episodes of me spouting rubbish. You could do that. It's easy.
And you know what I've learned in 266 episodes? That we keep finding new questions without answers.
We do. That's what research is all about, and it's great.
Yes, indeed. How are you, Fred?
I'm very well, thank you. All good. Still in lockdown.
Well, yes. Well, we've had ours extended a bit, and I think it'll be extended again. It's supposed to end this week, but it won't, because we've got 139 cases in our region now, and quite a few of those are in Dubbo, where I am, and they're trying desperately to haul it in. In fact, I got flagged by the health department as a casual contact, they call it. So I was at the same place at the same time as somebody who was infected. So I lined up for 3 hours yesterday to get my test, and I got the result at 3 o'clock this morning. They must stay up all night doing these tests. And I have a negative result, so I'm very happy about that. But yes, I think the hardest part for our government and the health department is getting people to do the right thing. The vast majority are, but they're just this handful of people that think the rules don't apply to them, and it's really causing trouble. And that's an issue all over the world. I mean, look at the lack of social distancing in Afghanistan right now. I mean, gosh. Yeah. That's another difficult problem, isn't it? Anyway, Fred, we've got a lot to get through, so let us begin. A new way to measure the mass of a black hole, a supermassive black hole. Guessing the thumb theory's not going to do it again? Oh, look at the black hole. No.
There's more to it than that. You need two thumbs. It actually is it's something that is not intuitive. It's not something you'd expect to be the case. But let's just do the recap that supermassive black holes, are, we believe, in the centres of all galaxies, certainly most galaxies. But when we look back in time, as we can do in the world of astronomy, because light takes a finite time to reach us, when we look back billions of years, we find examples of what we call active galaxies, which have at their centre a black hole that's consuming its surroundings very voraciously. And by that I mean that it has what's called an accretion disk. This is a disk of debris, gas, dust, probably a few old stars and solar systems thrown into it as well, swirling around the black hole. And it's that swirling that causes the energy that the accretion disk delivers. Basically, the accretion disk is bright in certain wavelengths of the spectrum because of this friction between all the bits of stuff. Now, what happens when you observe one of these distant and ancient, in fact, probably extinct now, actually, these active galaxies, which at their upper end are called quasars, by the way. The quasars are just the extreme examples of these active galaxies. What you see is in various different wavelength regimes, radio, infrared, you see a flickering of the brightness of the galaxy itself, the center of the galaxy. And this is due to, we think it's due to the accretion disk having, it's an inhomogeneous mass of matter. It's got lumps in it. It's got stars in it. It's got dust and gas, which are quite smooth. But because it's swirling around, when a big bit goes into the black hole, we think that's when this thing brightens up and you get a bit of a bright flicker.
Like chucking a log on the fire.
That sort of thing. That's a really good analog, actually. Throwing a log on the fire, I like it. So people have observed these flickers, for 30 or 40 years. We've seen them happening. I remember talking about these a long, long time ago when I was an astronomer at the Royal Observatory in Edinburgh. And so the flickers have intrigued people. Is there anything we can learn from them? And it turns out that there is. And so this is science that has been carried out in one of the universities, University of Illinois, Urbana-Champaign. If I hope I'm pronouncing that correctly.
Champagne, yeah, I think you got that right.
Yeah, it's different spelling though.
Oh, okay. It's the name of my street, by the way.
Oh, is it? I didn't know that. Yes, is that spelled the Illinois way or the French way?
I think it's the French way.
It probably is, I would think so.
It wasn't supposed to be called that. It was supposed to be called King George's Drive.
Okay.
But because there was a St. George's Terrace on the other side of town, the ambulance service or the council decided it was too risky to have two streets with similar names in the same town, just in case they went to the wrong place at opposite ends of town in an emergency.
Exactly.
So we had to change it. But then I discovered there's two streets within a kilometre of each other just down the road that are almost identical in name.
There you go.
So they missed that one. Anyway, I digress, as always.
So, yes, that's right. So, picking up the story again, there's a sort of pattern in these flickers. That's the bottom line. When you compare the flickers that take place over a short time scale with flickers that take place over a long time scale, which produce bigger brightness changes, and you can sort of balance these two together in a way that lets you discover what the mass of the black hole is in the middle. That's an extraordinary discovery. There is a signature, it's a fairly involved one, but there is a signature in this flickering that reveals just what size of object you're dealing with. And I guess you can kind of relate to the question, if you think of what's happening, you've got, a bigger black hole is going to produce a much more energetic accretion disk than a smaller one. And so that would allow you to perhaps draw the notion that, yes, there are things in that flickering, because that comes from the accretion disk, that will give you some insight into the mass of the black hole. So these scientists, what they've done is they've done this for a number, a number of galaxies with supermassive black holes whose mass is known, because there are other ways of determining the mass of a black hole. But it turns out that this one is extremely rigorous, if I can put it that way. It means you get a really good idea of the mass of the black hole in when you examine this flickering. It's a new diagnostic tool, if I can put it that way, for scientists to examine the mass of a black hole by relatively straightforward means, just recording the flicker and look at the way these large-scale flickerings and small-scale flickerings relate to one another. And I'm just going to...
So we're using all this high-tech, all these high-tech measurements of flickering and comparing black holes to the size of our sun.
Yeah, that's right. Well, we do, because we always give them in the mass of the sun, in terms of the mass of the sun. So a typical, I should have mentioned this, Andrew. Thank you for the reminder. A typical supermassive black hole will have a mass that is millions or billions of times the mass of the sun. The one in the centre of our galaxy, which is a quiescent black hole, it's not doing any of this stuff, making flickers and the rest of it, but it is a black hole of about 4.1 million times the mass of the sun. That's a really quite modest one. These ones that we're talking about now have masses usually in billions of times the mass of the sun, so they're much bigger.
Okay. With this data, what would we be able to do in the future with this discovery?
It means there's a much more, in some ways, easily accessible way of determining the mass of a black hole. All you've got to do is observe the flickering over a period of time, probably a matter of months, and then analyse that, and you get the mass of the black hole, which is a really neat and tidy method that doesn't need, some sophisticated algorithms to work it out. So, yeah, it's very successful. And I'm delighted to say I've just looked down the list of authors of this work, and one of them is from my old alma mater, the University of St Andrews in Scotland.
Nice.
Scotland's oldest university. Founded in 1413, and I was there a few years later.
Also the world's oldest golf
Indeed,
course.
That's right.
Yeah, Royal St Andrews. Never had the pleasure. I would love to play there,
place,
I don't think that's ever going to happen. Hard to get on, apparently.
Oh, yeah.
You've got to go into a lottery and all sorts of weird stuff. Yeah. All right, that's good news that they're in a position to learn a little bit more about black holes, one of the great mysteries of the universe. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.